So we are here again on the correction to the director's test for year 10, and now on question number 3. In this question, we are given that a binary operation star is defined on the set of real numbers R by x star y is x plus y minus xy if the identity element under the operation star is 0. Find the inverse of x, which is an element of R. You can pause the video and go over the question again. Now, we have a solution. X star y is x plus y minus xy. The identity element is 0 for this operation. So we want to find the inverse element. So remember that to find the inverse element, x star x inverse must give us the identity element. So by changing this operation in terms of x inverse, we are going to be having x star x inverse will be x plus x inverse minus xx inverse. So we have replaced the position of y with s inverse, and x operated with s inverse gives us identity element. And for this particular question, we have been given that the identity element is 0. So we are going to replace this by this such that E will be x plus x inverse minus xx inverse. And remember, E is 0. So E is 0 means that we are going to have 0 x plus x inverse minus xx inverse. So we see that 0 will be x plus x inverse into 1 minus x. So by rearranging, this place will be minus x, will be x inverse into 1 minus x, such that x inverse will be minus x over 1 minus x. Now, we can rearrange this by moving this minus downward. X inverse will be x over minus into 1 minus x. X inverse will be x over minus 1 plus x. So the x inverse will be x over x minus 1. So that is the x inverse of the binary operation given. So the inverse element will be an element of real number. For example, if we are having x as 2, 2 is an element of real number. So x inverse can be 2 over 2 minus 1. So whatever value or element you pick from the real number, if you operate it with this, you are still going to get a real number. So that is what it means to have x inverse as x over x minus 1. So this is the end of question number 3. In our next video, we handle question number 4. Until then, thank you very much.